Hello grade 12s and welcome to another mathematics lesson under the topic of sequences and series. Right now we're going to be looking at some end of chapter exercises. Here we go. So I modified that from siavula.com, so please take it down. Okay, so number one states calculate the value of n if summation of 17 minus 5b from b is equal to 1 to b is equal to n is equal to negative 710. So if it's like this, right, it's negative 710 is equal to 17 minus 5 from b is 1 plus 70 minus 5 b is 2 plus 17 minus 5 b is 3 plus others in between, then plus 17 minus 5 to the last term. So we can see from this Sn is equal to negative 710. B is not an exponent, so it's safe to assume that this is an arithmetic series, right? So I read an arithmetic series. Okay, well, A is T1, which is, what is T1? This is T1. 17 minus 5 times 1, which is 12. Now we need, so since we've established that this is an arithmetic series, we need D. D is T2, which is 7 minus T1, which is 12. 7 minus 12 is negative 5. N is upper bar, upper bar is N minus lower bar 1 plus 1. So N is just N. So you write your formula. The formula that we're going to be using is this one. Okay, we have the last term, right? So what is Sn? Negative 710 is equal to n over 2. What is A? A is 12 plus, what is L? This is L. 17 minus 5n. Plus 17 minus 5n. Multiply everything by 2. We have negative 710 times 2. Negative 1420. 2 times n over 2 is n. Negative 5n. 12 plus 17 is 29. Plus 29. So here we have 0 is equal to n times negative 5n is negative 5n squared. N times 29 plus 29n. This one goes to the other side, it becomes positive 1420. Oh my. So what to do? Let's take this to the other side. So everything, because all the signs change. 5n squared minus 29n minus 1420 is equal to 0. Just going to use the quadratic formula. N is minus, what is B? Negative 29 plus minus square root of negative 29 squared minus 4. A is 5. C is negative 1420. So for the overlap, all over 2, A is 5. So N is going to be let's start with plus. So N is 20, or N is negative 71 over 5. So the final answer is N is 20 because N is greater than 0. Okay, I hope that made sense. So number 2 states, given the geometric series, T1 is C plus 5, T2 is 2C minus 10, T3 is C plus 16. Determine 2.1 states, determine C. And you are given that C is not equal to -5 and C is not equal to 5. And C is an element of integers, right? So since we're doing with a geometric series or geometric sequence, we have a constant ratio, right? So remember, R is T2 over T1 is also T3 over T2. So we're going to say T2 over T1 is equal to T3 over T2. What is T2? It's 2C minus 10, right? What is T1? C plus 5. What is T3? C plus 16. T2, 2C minus 10. Then you cross multiply, right? This times this is 2C minus 10 squared. So it's going to be C plus 16, C plus 5. This squared on the left is going to be 4C squared. Their product times 2. 2C times negative 10 is negative 20C. Negative 20C times 2 is negative 40C. This squared is plus 100 is equal to C squared plus 5C plus 16C plus 80. Everything goes to the left. So it's going to be 4C squared minus C squared minus 40C. 5C plus 16C is 21C minus 21C plus 100 minus 8 is equal to 0. Simplify, we have 3C squared. Negative 40 minus 21 is negative 61C. 100 minus 80 is plus 20. So C is equal to minus B is negative 61 plus or minus square root of negative 61 squared minus 4. A is 3, C is 20. 2A, 2 times 3. So going to have C is C is 20 or C is 1 over 3. But the final answer is going to be C is 20 because we were given that C is an element of integers. 2.2 states show that the constant ratio is equal to 6 over 5. So the constant ratio is just R is T2 over T1. So it's going to be, what's T2? 2C minus 10. It's going to be 2 times 20 minus 10 over T1 is C, which is 20 plus 5. 2 times 20 is 40. 40 minus 10 is 30 over 25. So the final answer is R is, what's 30 over 25? 6 over 5, as it's there shown. Okay, I hope that makes sense. So number 3 states, calculate the summation of 8 times 3 to the power of negative k from k is equal to 1 to k is equal to infinity. So this is sum to infinity. Okay. So we're just going to equate this to, what's t1? 8 times 3 to the power of negative 1 plus 8 times 3 to the power of negative 2 plus 8 times 3 to the power of negative 3. And then it's an infinite, so it will always go on forward. Okay. Now, as infinity, what do we need? We need a and we need r. A, what is a? A is t1, which is 8 times 3 to the power of negative 1. It's 8 over 3. Remember, you don't round off in the intermediate steps. Now, we need to verify if this is indeed a geometric series. T2 is 8 times 3 to the power of negative 2 over T1 is 8 times 3 to the power of negative 1. So it's 1 over 3, right? Now we go to T3, 8 times 3 to the power of negative 3. So it's 1 over 3. So R is T2 over T1, which is 8 times 3 to the power of negative 2 over 8 over 3. It's 1 over 3. So formula S infinity is equal to A over 1 minus R. What is A? 8 over 3 all over 1 minus, what is R? 1 over 3. Oh my, okay. 8 over 3, 1 minus 1 over 3. So S infinity is 4. I hope that makes sense. You can equate this to 4. Still fine. Number 4 states, write the sum of the first 25 terms of the following series in sigma notation. So we know that it's a series, right? But we don't know whether it's an arithmetic or a geometric. Okay, so first A is T1, which is 36. So this is T1, this is T2, this is T3. Now we need to determine whether it's arithmetic or geometric, right? Let's start with arithmetic. D is T2, which is 30, minus T1, which is 36. We get negative 6. T3 is 25, minus T2 is 30. Negative 5. So we get two different answers, negative 6 and negative 5. So arithmetic is out of the question. Geometric, T2, 30, over T1, 36. We get 5 over 6, right? T3, 25, over T2 30. We get 5 over 6. So this is an geometric series. R is T2 over T1, which is 30 over 36, which is 5 over 6. And then first 25 terms, right? So it means that n is 25. So if we were to write it in sigma notation, you have the summation of, what is A? A is 36 times, what is R? 5 over 6 to the power of n minus 1, from n is equal to 1 to 25. Alright, I hope that makes sense. Okay. Number 5 states, calculate the value of m if the summation of 4 times 6 to the power of t minus 1 from t is equal to 1 to t is equal to m is equal to 6,220. So what this tells us is 6,220 is 4 times 6 to the power of 1 minus 1 plus 4 times 6 to the power of 2 minus 1 plus 4 times 6 to the power of 3 minus 1 plus others in between plus 4 times 6 to the power m minus 1. Sorry for the lack of space there. So here Sn is 6,220. A is T1, which is 4 times 6 to the power of 1 minus 1. Which is 4. Now, since the variable is an exponent, so this is geometric. R is T2 over T1. What is T2? 4 times 6 to the power of 2 minus 1, which is 1. We don't write it, over T1, which is 4. So R is 6. So first you write the formula for geometric series. Sn is equal to A times R to the power of n minus 1 all over R minus 1. What is Sn? 6,220 is equal to, what is A? 4. What is R? 6 to the power of n, right? Minus 1 all over, what is R? 6 minus 1. 6 minus 1 is 5. 5 times 6,220 is 31,100. 4 times 6 to the power of n minus 1. Divide both sides by 4. We get 7,775. 6 to the power of n minus 1. Take this to the other side. 7,776. 6 to the power of n. Log both sides. N times log 6. So n is this, log 7,776 over log 6. N is 5. Our n is m, so m is 5. Because our n was supposed to be upper bar, which is m, minus lower bar, which is 1, plus 1. So n is m. Okay, I hope that made sense. Please keep practicing, and I hope to see you again.